All right, let's do this thing. We're not doing 1 and 2. Let's just jump right here to example 3. We're going to find an equation of a line tangent to the graph of f of x is equal to x cubed plus 4x at the point 1, 5. Okay. So that's the other thing about a tangent line. It's tangent at a specific point, right? So if we look at this graph, we're coming to a specific point. That's the important part. This is this whole graph, but I want to know what's happening at a specific point. That's a derivative. A tangent line is a derivative. So does it use the word derivative so far? No. But what are my tip-off words that tells me I'm finding a derivative? Yes, tangent. Tangent, good. Okay, so let's go ahead and write it since we just learned it. I'm going to take the limit as h approaches 0 of f of a plus h minus f of a all over h. And this is the same thing as f prime of a. All right, now x is a variable that we've used in the past in terms of difference quotient. You can use the variable x again. I don't care, right? It doesn't matter to me. The book puts this a in there, so I'm just trying to be consistent. So we are looking at this equation, and then we're going to put it at this point. The very first thing you have to do is find the derivative of this. So I want the generic derivative. All right, so we're going to do f prime, and I'm going to write x in here, f prime of x, because I want to find this particular derivative. So I'm taking the limit as h approaches 0 of, now remember, we're going to plug this, now I'm using x, into both variables. Remember the difference quotient, we have to plug that in. So I have x plus h cubed plus 4 times x plus h minus the actual function x cubed plus 4x all over h. Now, ladies and gentlemen, we algebra. Dun, 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 dun. So on this problem, when I'm looking here, this x plus h cubed means that you are going to multiply x plus h out 3 times. Oh, we're not going to do that. We have Pascal's triangle. I don't know if you've ever heard of that before. Most of the time, students haven't heard of Pascal's triangle, so let's talk. Pascal's triangle. Pascal starts with a 1 and it goes down all the 1s. Then on this third line, it's 1. You add these together. 1 plus 1 is a 2. And then you end on a 1. Then you do it again. You always start with a 1 and then you add. 1 plus 2 is 3. 2 plus 1 is 3. And then you end in a 1, making the triangle. If I were to go the next step, 1, and then 3 plus 1 is 4, 6, 4, and you end with a 1. Do you see where this is going? And then you just keep going. Here's the beauty of Pascal's triangle. Pascal's triangle, these are the coefficients. Oh my, let's try again, shall we? First of all, I couldn't read my writing. Second, let's make sure this spelled it right. There it is. Coefficients of binomials to an exponent. So we have always said square multiply square, right, times the 2. That's this part. So this one, these are the coefficients if I have whatever squared, right? X plus 2 squared, you know, you multiply them together by 2 in the middle. That's Pascal's triangle. We need these coefficients. This is going to be for us, this x plus h cubed, where I have a cube, that's line 3. So that's going to hang out right here. This one goes up. Oh, that looks confusing. you go. So this cubed, those are going to be my coefficients. And then you go with the exponents. So it looks like this. All right, and once you get Pascal's triangle, it looks a little daunting now just because we're learning it. But once you look at it, bam, 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 bam. You just throw those out there super quick. You don't have to try to do all the work of multiplying that stuff out. So I have my limit as h approaches 0. We haven't taken a limit yet. We're still algebra. So you write that limit notation in there. That's an operation. You still can't lose it. Still a limit. You learned something. Now I expect you to be able to apply it. That's what we're doing. Okay. So for this x plus h cubed right here, I'm going to change my color just so you can see the diff. I have a coefficient of 1 to start us off, and then we have x cubed. So 1x cubed plus, and because this is plus, it's all plus. If it were minus, then we would swap back and forth, but that's a conversation for a different day. Then I have a coefficient of 3. I go down in one of the x's and pick up an h. Your exponents should always add to 3 because this is a cube. Plus 3, right? That's my next coefficient. I'm going to go down in x and pick up another h. Plus my coefficient of 1, and then I go down in x and pick up another h. And there it is. Easy, right? It is. Once you get that down, once you get down the, I'm going to move this down. I'm out of room. Once you figure out Pascal's triangle, it is really easy how to pull that off. Okay. Now let's do the rest of this. I'm going to take this 4 and distribute it. So now I have plus 4x plus 4h. And I'm going to take this negative and distribute it. And I'm left with a negative x cubed minus 4x, still all over h. And we keep algebra. Here's a positive x cubed and a negative x cubed. Here's a positive 4x and a negative 4x. You see this? And it will always cancel out like this and make it super nice. Let's clean it up. F prime of x is equal to the limit as h approaches 0 here of 3x squared h plus 3xh squared plus h cubed plus 4h all over h. Right? Okay. Now notice there's an h in common with everything, so factor that out of the numerator. Still haven't taken a limit yet? Still writing the notation. So I've got 3x squared plus 3xh plus h squared plus 4 all over h. And now this h cancels out with this h. Cool, right? Now, when you take your limit, as I'm plugging this in, f prime, and honestly, if you wanted to take your limit at that last step, I would have been super on board with that. Plus 3xh plus h squared plus 4, just so you don't have to keep writing it over and over. Now I'm going to plug this in. When I plug in a 0, I'm plugging it in for both of those h's, which means this value becomes 0, and so does this. Which tells me that my derivative here, I'm going to plug this in, f prime of x is equal to a 3x squared plus 4. And what's a derivative again? The slope of the tangent line. So any slope. So this is my generic slope of any tangent line. All right? That is a slope. So any slope of the tangent line, that's what we need to know. Well, if we rock ourselves right back on up here, we specifically want to know what's happening at the point 1, 5. So let's bring it back down. The point 1, 5, I know that my slope here at the point 1, 5 is going to be f prime of 1. So 3 times 1 squared plus 4. So at 1, my slope is 7. So now I have a slope and I have a point. So to make my equation of the line, we just go with point-slope form. So y minus 5 is equal to 7x minus 1. Y minus 5 is 7x minus 7. And y is equal to 7x. You're adding 5, so minus 2. So the equation of the tangent line at that point for that function is y is equal to 7x minus 2. All right. If I had a different point, I could still find the slope. You don't have to keep finding the derivative over and over again. You found the derivative. Now this is any slope I want, any point that I want out there known to man on that graph. This is going to give me the slope for that function. Okay. Okay, good, good. Slope of that line. All right, let's do another.